Very good morning to all of you students. Welcome to EduCourse tutorials. So today we are going to discuss about the relation between focal length and radius of curvature. We have earlier discussed about the topic reflection of light, and we have also discussed about the plane mirrors and spherical mirrors. Now we are going to drive a relation between the focal length and radius of curvature. So for this we will draw a diagram. Let us assume that this is a concave mirror. Okay, concave mirror of small aperture. Okay, concave mirror of small aperture. Now we will draw a principal axis in the x direction. This point will represent the midpoint of this mirror. Okay, so this will be A B. Our mirror is A B. Okay, now let us assume that a ray which is going parallel to the principal axis and strike with the surface of this concave mirror at some point E. Okay, now the focus of this concave mirror can be represented by F, and after striking we know that the rays parallel to the principal axis after striking will go through the focus. Okay, so it will pass through the focus. Now here C is the center of curvature, and we will draw a normal from C to the point E. Okay, so this is the incident ray and this is the reflected ray. Okay, now the angle between this line is representing the normal, and in law of reflection we have discussed that the angle of incidence is always equal to the angle of reflection. Okay, for also plane mirror and also the spherical mirrors obey this law. Okay, so this will be the angle of incidence represented by angle I. Now here the angle ET angle will be angle of reflection. Clear? Now we will see that the ray PE and CP are parallel to each other, as I have told you. So PE and CP are parallel to each other. So angle I and angle ECF will be alternate angle. So we can say that angle I will be equal होगा किसके, angle CEF, and also because angle I is equal to angle R, so angle ECF will equal to the angle CEF. Clear? Now let us assume a mirror of small aperture. Clear? And PE is parallel to PC. Okay, and what is PE? PE is the incident ray, and PF, here PF is the, F is focal point, so or we can say that focus of this mirror. So PF can be denoted by small f and PC can be denoted by capital R. So what is angle PEC? Angle PEC is angle of incidence equal to angle I, and angle CEF is equal to angle R, which is angle of reflection. Okay, now as we know, angle PEC will be equal to angle CEF. Clear? From law of reflection. Law of reflection clearly says that angle of incidence will be equal to angle of reflection. Okay, so this will be our first equation. Now, as PE parallel to CF, PE parallel to CF, so angle PEC will be equal to angle ECF. We can say it as alternate angle. Okay, and in equation 1 we know that PEC is equal to CEF, so PEC is also equal to CEF. So from first and second, angle CEF will be equal to angle EC. Now by using this equation we can say that angle Q is equal to angle R. It means angle CEF is a isosceles triangle, and in isosceles triangle two sides are equal. It means CF is equal to FE. Okay, from equation 3 we can say that CF will be equal to FE. Okay, now we have already discussed that the mirror AB has very small aperture. Small aperture means this E point will be very close to point P. So we can say that PF will be equal to EF. Okay, PF will be equal to EF because P is very close to E. Okay, now CF is equal to FE, so we can say that CF will be equal to PF. Okay, and CF can be written as PC minus PF, so it can be written as PC minus PF is equal to PF, or here I am writing it here, PC will be equal to PF plus PF, or PC will be equal to 2PF. And what is PC? PC is the radius of curvature, can be written by R. Okay, and we will put here minus sign because it is in the left side, and PF is the focal length, so we will put here minus 2F, and minus minus will be cancelled out, so F can be written as R by 2. This is the relation between focal length and radius of curvature. Okay, so I hope students this lecture is well clear to you. If it is interesting, then like, share and subscribe. Okay, thanks to all of you. Have a nice day.